Hey guys, last round of 6.1 questions. We're going to talk about question 32, which I thought was pretty interesting. Um, the main purpose of this question is to look at this matrix A and try to determine what does it do geometrically. So first, we just pick two random vectors. So I just picked the vector u to be 1, 1, 1, 1 and v to be 2, 2, 2, 2. And the first thing we're going to do is just look at the relationship between some of the column vectors in matrix A. So A1 dot A3 means I'm going to dot this one with this one. So it would be 0.5 times 0.5, so that's that times that, plus 0.5 times negative 0.5, so that's this one and this one, plus 0.5 times 0.5 plus 0.5 times negative 0.5. And pretty quickly you see that this is the same as this, and this is the same as this, but this is just the negative of that. So we end up getting 0. And similarly, A1 dotted with A2 is 0. A2 dotted with A3 is 0. And A3 dotted with A4 is 0. You can kind of easily see that. Like, let's look at A3 and A4. We get positive 0.5 squared, positive 0.5 squared, negative 0.5 squared, negative 0.5 squared. So everything ends up canceling out. So that's all that was needed in part A. Now we start doing some computations with the random vectors that we chose. So to get the norm of u, I'm going to take u dotted with itself and then take the square root of that. So it'd be 1 squared plus 1 squared plus 1 squared plus 1 squared. So for the norm of u, I end up getting 2. For the norm of v, I end up getting 4. 2 squared plus 2 squared plus 2 squared plus 2 squared. Now let's compute AU so that we can get the norm of AU. So AU is going to be 0.5. So let's actually write it. I'm not going to write the whole thing because you'll see the pattern pretty quickly. So when I do A times U, my first entry is the first row times this column. So 0.5 times plus 0.5 plus 0.5 plus 0.5. And that ends up equaling 2. Then I'm going to have 0.5, 0.5, negative 0.5, negative 0.5. So 0.5 plus 0.5 plus negative 0.5 plus negative 0.5, I end up with 0. And you can check, I'm going to end up with 0 again for the rest of them. For AV, I would do the same thing, except I'd put V here. So what I end up getting is 4, 0, 0, 0. See, I chose my vectors really nicely. Now to compute the norm of this, I end up just getting, it'd be the square root of 2 squared plus 0 squared plus 0 squared plus 0 squared. So end up with 2. Interesting, the norm of U was 2. The norm of AU is 2. Let's see what happens with AV. Oh, interesting, I got 4. They're the same. So it looks like A maybe doesn't change the norm of vectors because U and AU have the same norm, but I don't know that for sure yet because my vectors are really nicely chosen. So now let's look at the angle between U and V. So they tell you to use equation 2, which is the one that says that U dot V equals the norm of U times the norm of V times cosine theta. So U dot V, did I compute that already? I don't think I've computed it already, but we can do it really fast. 2 plus 2 plus 2 plus 2, it's 8. The norm of U we did compute, that's 2. The norm of V we computed, that's 4, which is also 8. So what we find is that cosine of theta is going to be 8 over 8, which is 1. And you could figure out what that means that theta is. If cosine of theta is 1, that means the x-coordinate is 1, so that's either 0 or 2 pi. Alrighty, now if I want to do the angle between AU and AV, I would do similar thing. So AU was, where is it? 2, 0, 0, 0. AV is 4, 0, 0, 0. So the dot product is 2 times 4 plus 0 plus 0 plus 0. So that's 8. And AU was 4, or was 2, and AV was 4. So again, we find that cosine of the angle between AU and AV is 8 over 8, which means theta is again the same, or theta 2, the angle between AU and AV, is either going to be 0 or 2 pi. Okay, so maybe we can make a conjecture that the angle, that A doesn't change the angle between vectors either. But to be really sure, we would need to try another set of random vectors. So this time I chose 1, 2, 3, 4, 5, 6, -7, -8. So if you compute the magnitude of this one, you get square root 30. When you do A times U and get the magnitude of that, you also get square root of 30. So it seems like our original conjecture might be true. V, AV, I computed the same magnitude on those. When I computed cosine of theta for U and V, I got the same thing as when I did AU and AV. So my conjecture is that A does not change magnitudes. And A does not change the angle between vectors. So basically that means if U and V were like this, and maybe I do AU and AV, so after I do A to both vectors, this angle and this angle end up being the same. That's our conjecture. Now, to really check this precisely, I would have to do it with variables like U1, U2, U3, U4, and V1, V2, V3, V4. But it's a little more concrete to just use actual integers here. So that was number 32. You could have picked any vectors you wanted for U, V, U2, and V2, but you should have ended up with a similar conjecture to mine. Alrighty, so that's it for 6.1. Let me know if you guys have any questions, and we'll talk soon.